Hello everyone, my name is Guillem Cordoba. I'm a developer at Darksoil Studio, and this is a short introductory video on what is Holochain. Holochain is a peer-to-peer application framework, which means that you build peer-to-peer applications with it. Each Holochain app or hub actually creates its own separate peer-to-peer network. So let's see some examples. You could have a social network hub, and here we see Julieta, Yvonne, Antonella, etc. 10 end users with their respective nodes that are maybe texting with each other or posting tweets. You could also build a chess hub. So in this case, we have 4 end users playing chess with each other. Or you could also have a digital token hub. So NFTs or cryptocurrencies. And here we see a network of 8 nodes trading with each other. Playing by the rules. The idea of each network is the hash of the validation rules of the hub. Validation rules determine which actions are valid or invalid to take in the network. To participate in a network, a user has to install that hub in their Holochain node. Therefore, all nodes participating in a given network are actually committing to behave according to the rules of the network in advance. Let's see what the process looks like. So here is a simplified version of what the validation rules for the chess hub would be. It has a validate function here, which given an action, if the action is a valid chess move, returns that the action is true. Otherwise, returns false. These validation rules mean that the only action that's valid in this network are chess moves. So we take this file, we hash it, and the resulting hash is actually the ID of the network. So before installing the application, you know the validation rules and you install the app actually committing to behave according to the rules. So you know that everyone in the network is actually committing to do so. Integrity. Each node participating in a hub has a public-private key pair, and all communication between nodes is signed and encrypted using that key pair. The end user is always in control of the private key, and actually it's end users, usually, the ones that are running their own node in their own computers. Each node maintains a signed chain of all the actions they have taken in a specific hub. So let's see how this works. Here we have a network of 8 nodes, and if I click on one of them, this is the chain of actions that that network took in the network. Right now, we only see 3, and these are the initial 3 that all the nodes, when you install the hub, create. So if I go to Krista, same 3 actions. If I go to Jania, same 3 actions. Now, if Jania creates an action, you can see the new action gets appended and linked to the previous chain of actions. But if I go back to Krista, Krista's chain hasn't actually changed. Each of the nodes are the ones controlling their chain of actions, and the chain of actions, it's completely separate per node. So if I go back to Chris and I create 4 actions, no other node actually has had their chain of actions changed before because of that. Data needs to get published if the only thing that Holochain did was just storing the chain of actions, then no other node would know about that data. Each time a user attempts to create an action, their node first validates whether that action is valid or not. If the action is invalid, the node rejects the attempt and nothing actually gets published. But if the action is valid, the action is published published to the other nodes in the network. Let's see this in action. Let me go to Runis, and let's say that the user actually clicks the button to, for example, in the case of a chess hub, move the pawn 3 squares. I'm going to create an invalid action. The request gets to the Holochain node, and the Holochain node validates whether that move is valid or not, sees that it's invalid, and then directly rejects the attempt. Notice here, no new action got appended to the chain. If instead Runis actually behaves correctly and just advances the pawn 1 square, so create valid action, the request gets to the Holochain node, which checks whether the action is valid or not. In this case, it's actually valid, so they actually publish the piece of data to other nodes in the network, which then they store. So now, actually, each node is responsible for keeping a slice of all the data available. But if a node goes offline, the network recruits another one to hold the pieces of data they were holding. Therefore, all published data is guaranteed to be available as long as there is a node in the network. And actually, after a network partition, nodes merge all data that was published in all the partitions, which makes Holochain partition resistant. Let's see how this works. This is a network of 8 nodes as well. Let's say that Alicia creates an action. We know how this works now. This new action, if we click on it, we can see the yellow nodes are the ones responsible for keeping this action in the network. In here, we only see 3. This is a simulator, but in a normal Holochain network, this would be more like 25 nodes. So what happens if Aurea disconnects their node? Let's actually remove it. So Viva and Blondel recognize that Aurea disconnected and recruited Alicea for the network to always have 3 nodes holding the piece of data. So let's disconnect most of the nodes, see what happens. Let's disconnect Blondel and Viva and Janet and Alicea. So as you can see, nodes are shutting down, but the data is still available because the nodes see that there are not enough nodes holding the data, so they recruit other ones. So if at least one node is available in the network, all data is guaranteed to be available. When each node receives a publish request, they first validate that the action is actually valid for themselves. This is known as peer validation. If it's valid, they make the data available to other peers in the network. This is normal functioning of the app, no problem at all. If it's not valid, they actually produce a verifiable proof of cheating called warrant. If you remember, we talked about every action being signed by the author's private key. So if you receive an invalid action that's also signed by the author's key, it's trivial to convince anyone that certain author tried to create an invalid action. In that case, they sound the alarm and send the warrant to everyone in the network. When a node receives a warrant, they first validate whether the warrant is correct for themselves, and then they disconnect from the warranted node. So let's see this in action. Here we have a network of 8 Holochain nodes in which Esme is actually a bad actor. Here, this means that they have downloaded the Holochain source code and they have commented out the parts of the code that validate whether an action is valid or not before trying to publish the action. So this means that this Holochain node is perfectly happy to publish whatever kind of action to the network, whether valid or invalid. I'm going to select it, and let's actually start by creating a valid action, see what happens. The create request comes into the Holochain node. It doesn't validate whether the action is valid or not. It just publishes it. So the publish request goes to the network. And on receiving the publish request, the nodes validate whether that action is valid or not. They see that it's actually valid. They store it. They serve it to the network. That's that. No problem at all. Actually, at this point, there is no way to tell that Esme is a bad actor. So we are just accepting it as a participant in the network. Now onto the invalid action. Let's actually try to create an invalid action and see what happens. So create invalid entry is requested on the Holochain node. It doesn't validate that the action is invalid. It just tries to publish it. The nodes receiving the publish validated see that it's invalid and start producing warrants to everyone else. So let's run this through, see how it ends. Okay, so as you saw, Esme got completely disconnected out from the network. So effectively, Esme has been booted out of the network completely just by the warrants telling everyone that they should disconnect from Esme. Importantly, also, the action, the invalid action that they created is not available to as a normal action in the app. It has been discarded. Okay, but what if more than half the nodes are bad actors? In this case, that would mean that they declare invalid actions are valid, so they try to support invalid data being published to the network. So in the previous case, what if Elme got help? What happens is that other nodes in the network are also able to detect that and also disconnect from them. So let's see this in action. Here we have a network of 8 Holochain nodes in which actually 5 of them are bad actors. So they try to support each other in saying, yeah, this invalid action is actually valid. So let's go to tunnel, and same as before, let's just create an invalid action, see what happens. So create invalid entry is called, and publish request goes out, validation runs, they see that it's invalid, they start produce the warrants, and the bad actors say that the warrants are not, like, the invalid action is valid. So all the honest nodes also disconnect from the ones that don't admit that the action is invalid. So in the end, you end up with Adrian, Shandy, and Judita, which are the honest nodes, just being connected with each other. So all the bad actors, even if they are majority, have been booted out of the network. That's it. We actually have a training coming up in February, and it's an online 2-week course to learn how to build hubs. If you want to learn more, go to darksoil.studio/HC training. Thank you so much for watching.